Hello, good morning. I'm Hemant Soyal and today I'm going to give a brief idea about Sun's atmosphere. Okay, so let's start. Now first see what is Sun. Sun is a big ball of gas which contains 92% hydrogen and 8% helium. Compared with the billions of other stars in the universe, the Sun is unremarkable. But for Earth and other planets that revolve around it, the Sun is the center of attention. It holds the solar system together, provides life, giving light, heat, and energy to the Earth. The Sun formed more than 4.5 billion years ago when a cloud of dust and gas called a nebula collapsed under its own gravity. The Sun is 109 times wider than Earth and it accounts for more than 98% of the total solar system mass. If it was a hollow ball, more than a million Earths could fit inside it. But the Sun isn't hollow. It is filled with gases and electrically charged particles called plasma. The atmosphere of Sun is composed of several layers, mainly the photosphere, chromosphere, and the corona. These regions have substantially different properties from each other. So here you can see the structure of Sun. There is a core and followed by it there is a radiative zone, convection zone, photosphere, chromosphere, and the last is corona layer. Energy is generated in the core region where the temperature is about 15 million Kelvin and the density is 150 gram per centimeter cube. At the core region, reactions consume hydrogen to form helium, therefore a large amount of energy is released. Radiative zone and convective zone are used to transfer energy from core to outer surface of Sun. Photosphere is marked by bright bubbling granules of plasma and darker cooler sunspots which emerges when Sun's magnetic field is disturbed. The next layer is chromosphere which emits reddish glow. It is hotter than photosphere. It conducts heat from the interior of the Sun to its outermost layer, the corona. The temperature of chromosphere is higher than the photosphere. Corona is the third layer of the Sun's atmosphere. It can only be seen during a total solar eclipse as well. It appears as white streams or plumes of ionized gas that flow outward into the space. Temperature of coronal layers is very high. Now there is a phenomena which occurs at the upper layer of corona that is known as solar wind. It is actually a collection of energized charged particles, primary electrons and protons flowing outward from the Sun through the solar system. This plasma is continually heated and cannot hold the Sun's gravity. Therefore, a large amount of electrons flow from the Sun towards the solar system, and this is known as solar wind. Sun rotates on its axis once in 27 days. This rotation was first detected by observing the motion of sunspots in the photosphere. These sunspots are dark in color, planet-sized regions that appear on the surface of Sun. Sunspots are only dark in contrast to the bright face of the Sun. But if you could cut an average sunspot out of the Sun and place it elsewhere in the night sky, it would be as bright as full moon. So these are dark in comparison to the bright face of the Sun. Okay. So these sunspots are indicators of disturbance in Sun's magnetic field. Whenever there are sunspots, then there will be a disturbance in magnetic field, which can generate energetic solar events like solar flares and coronal mass ejections. The number of sunspots on the surface of Sun varies from year to year. It means they are not constant. The rise and fall of the cycle is 11 years on average. It means the cycle of sunspot is of 11 years. Here you can see there is a graph between the number of sunspots and year. So you can see there is a lot of variation in the number of sunspots. A peak in the sunspot is referred to as a time of solar maximum. Where there is a maximum number of sunspots, that time is referred to as solar maximum, and where there is a minimum sunspots, that time is known as solar minimum. Okay. Now we will see what is the impact of Sun on space weather and how it impacts the climate. The energetic particles from the Sun penetrates into the atmosphere and change the chemical constraints. Space weather and terrestrial weather are influenced by the small changes made by the Sun undergoes during its solar cycle. The duration of solar minimum also impacts the Earth's climate. During solar minimum, there is a maximum amount of cosmic rays, high energy particles, which are reaching towards the earth. These cosmic rays can create nucleation sites in the atmosphere, which seed cloud formation and create cloudier conditions. So that's how the sun impact on the space weather and how it impacts the climate.